Good morning, scholars. Welcome back to the channel. This morning we're continuing our fractions and we're looking at reducing fractions. Now you must master reducing fractions before you can go on to the basic computation parts of fractions like adding, subtracting, multiplying, dividing. You must master this part first, reducing the fractions. So what do we mean by reducing a fraction? To reduce a fraction, we divide both the numerator and the denominator by the same factor or the common factor. And we are usually asked to reduce the fraction to its lowest term. That means as far as we can go until we can't reduce it anymore. Now, if you are still not familiar with what I'm talking about, denominator, numerator, go ahead and look up the video that was done on the introduction to fractions. The numerator is the number at the top of the fraction bar and the denominator is the number at the bottom. That's what we mean. So we are asked to reduce the fractions to their lowest terms. We're going to try to see if we can find a common factor, a number that can divide into the numerator and the denominator, and we're going to divide it so that we can cancel or reduce the fractions. So we look at 2 and 4. Can you think of a number that can divide into 2 and it can also divide into 4? Apart from 1, we know that 1 can go into all the numbers, but if we divide by 1, we're going to be left with the same fraction that we started with. So it doesn't make any sense to divide it by 1. We're trying to reduce the fraction. So we can use 2. 2 can go into 2. So what we do when we divide, we cross through the number. You don't have to. I'm going to show you another way of doing it without crossing through. But I am going to be crossing through. But here's another way you can do it. You can say 2 divided by 2 gives 1, and 4 divided by 2 gives 2. So we have reduced 2 over 4, it is now 1 over 2. It's actually the same fraction. We have not changed the fraction. We have not changed the overall value of the fraction. We are just expressing it in a simpler form. So when we reduce fractions, we actually end up with equivalent fractions. That also you can check the video that was done on equivalent fractions. For these sets, I'm going to do it like this to show you that we're actually dividing by the same factor, the common factor. For the others, however, I'm just going to go ahead and strike through, right, to cancel it through. So here we can divide both of the numerator and denominator by 3. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So also 3 over 6 is a half, just like 2 over 4 is a half. These are equivalent fractions. Alright, let's see. We can also divide 9 and 12 by 3. We can use 3 for those as well. So let's go. 9 divided by 3 gives 3, and 12 divided by 3 gives 4. So we reduce 9 over 12, and we are expressing it in its simplest form as 3/4. 3 over 4. How about 7 over 14? 7/14. Well, 7 can go into 14. So if we divide them both by 7, we should get a simpler form. 7 divided by 7 is 1. 14 divided by 7 is 2. So we're getting a couple of halves here. 2 over 4 is a half. 3 over 6 is a half. 7 over 14 is also a half. So many fractions can be reduced to a half. They are equivalent fractions. Remember, check that video that was done on equivalent fractions. So let's go. We have a 5 in the numerator and 25 in the denominator. Can you think of a number that can be divided by 5 and 25? Well, 5. So let's divide them both by 5. 5 divided by 5 is 1. 25 divided by 5, that gives 5. So 5 over 25 reduced to its lowest terms is 1/5. We can't reduce it any further. Alright, so for now, I'm not going to set it out to show you what we're dividing by. I'm just going to go ahead and divide them, cross through the number to show the result that we get after we divide. So, if you have two numbers and they both end with zeros, we know that 10 can go into them. 10 can divide equally into any number that ends with a 0. So we can actually do this. We can say that 0 cancels the other one. What we mean when we say that is just a terminology. We say we cancel the zeros. What we're really doing is dividing by 10. We're showing that we know that if the number ends in a 0, it is a multiple of 10. So 10 can divide into it. And we can just cross through the 0 to indicate that we have divided by 10. So now we're left with a half. So that one was pretty straightforward. So whenever you're reducing fractions, check to see if there are zeros at the end. But remember, you can only cross them through in pairs. So if you had 2 zeros down here and only 1 up here, you would still be left with one of them down there. It has to be that one to that one. Or if you had 1 here and 1 here, you could cross those two as well. But you can't just say all the zeros cross up. It has to be done in pairs. One at the top with one at the bottom. 15 and 20. There's a 0 here but none up here. So we can't do that trick that we did up top. We can't do that trick right here. But we know that if a number ends with 5, 5 can go into it. If a number ends with 0, 5 can go into it. So we're going to divide them both by 5. 5 goes into 15 3 times. 5 goes into 20 4 times. So our reduced fraction is 3/4. 15 over 20 can be reduced to 3/4. Here we have 3/4. Okay, so we know that this is the simplest form of this fraction. So we are going to just go ahead and write back the 3/4. It cannot be reduced any further. The only common factor of 3 and 4 is 1. And we know that if we divide something by 1, we're going to get back the same thing. If we keep doing it, we're going to get back the same thing. So we're not going to go to that futility. We know that this cannot be reduced any further. Sometimes your teacher will give you a fraction like this, which he or she knows it cannot be reduced, just to see if you really understand what you're doing. So you won't be there bursting your head trying to reduce something that cannot go any further. Can't be any simpler. 3/4 is the simplest form of this fraction. So we just write it back. Don't leave it blank and then the teacher doesn't know whether you understand it can't be reduced or you just don't know what to do with it. Write it back to say it cannot be reduced any further. You have to show your teachers that you're on top of things. You know what you're doing. Because teachers will put things, it's not that they like to trick you up or they like to, to catch you, but they just want to know that you really get the concept, you really understand what you're doing. And some students, if they see something given, they will just want to feel that something has to be done to it. But in some cases, there's nothing you can do. Just write back what you were given, rewrite it to show that you understand it is in its simplest form already. There is nothing more that can be done to it. 6 over 8. Looking at these, they are both even numbers. So we know that they can be divided by 2. So 2 into 6 goes 3 times, 2 into 8 goes 4 times. Alright, so again, we have our 3/4. So the 3/4 is making itself, it's representing this morning. See that? I wonder if we'll come upon any other 3/4. So all these fractions are equivalent fractions. They reduce to the same thing. You see that? 9/12, 15 over 20, 3/4, 6 over 8. They are all equivalent because we can reduce them all to the same 3/4. Alright, check that video that was done on equivalent fractions. How about 7 over 8? Can this fraction be reduced? The only common factor of 7 and 8 is 1. There is no other number that can go exactly into 7 that can also go exactly into 8. Therefore, 7 over 8 is already in its simplest form. We're going to rewrite it to show that we know that it's already in its simplest form. Just say, I cannot be tricked. I cannot be tricked about reducing fractions. I know this is already in its simplest form. I'm not going to waste any time trying to reduce it any further. Alright, so how about 5 over 9 then? How about 5 over 9? What are you going to do with 5 over 9? Is there any number that can go exactly into 5 and exactly into 9 without leaving a remainder? Only number 1. Again, this is already in its simplest form. Just say, I cannot be tricked. You can say that, right? I cannot be tricked. How about 4 over 16? Well, if you know your 4 times table, you know that 4 can go into 16. And 4 can go into itself. So 4 goes into itself 1 time, 4 goes into 16, 4 times. So the simplest form of 4 over 16, 4/16, is a quarter. That's as simple as we can bring it down, reduce it. How about 3/15? Okay, 3 can go into itself, 3 can go into 15, 3 goes into itself once, 3 goes into 15, 5 times. So 3/15 can be reduced to 1/5. 4/6. How about 4/6? They are both even numbers. So 2 into 4, 2 times. 2 into 6, 3 times. 2/3. 2/3 is the simplest form of 4/6. We can't reduce it any further. How about 9/10? Which number can go into 9 and can also go into 10? Actually, only 1. So 9/10 is as simple as we can get this fraction. Right? Can't reduce it any further. Alright, so we have a couple more to go. So let's look. We have 18 over 20. Which number can go into 18 and can also go into 20? We know we can use 2 because they are both even numbers. So 2 into 18 goes 9. 2 into 20 goes 10. So that's 9/10. Here we have 4/4. 4/4. How do we reduce that? 4 goes into itself once. 4 goes into itself once. So that's 1 over 1, which is 1 whole. Remember, any number expressed over itself is a whole. 4 over 4 is a whole. 10 over 10 is a whole. 20 over 20 is a whole. How about 2/10? 2 over 10. 2 goes into itself once. 2 goes into 10 5 times. So that's 1/5. I'm almost sure I saw 1/5 here and here. So that means these are equivalent fractions. 5 over 25, 3 over 15. Oh, I have 5 over 25 again. Let me just change this then to 35. I repeated that one. So 2 over 10, 3 over 15, 5 over 25, they all can be reduced to 1/5. Whenever we're able to reduce fractions to the same simple form, we know that those fractions are equivalent fractions. Alright, so I did a quick change because I'm realizing that it's repeated. I did a quick change to that. So now we have 5 over 35. We know once a number ends with 5, it can be divided by 5. That's a given. So let's just go and divide it by 5. 5 goes into 5 once. 5 goes into 35 7 times. So the reduced form is 1/7. 3/8. What about 3/8? Is there any number that can go into 3 that can also go into 8? Well, only number 1. There's no other number that can divide equally into 3 and equally into 8 except for number 1. And we know that if we divide by 1, we're going to get the same fraction. So we're just going to go right back and put 3/8 to show that we understand this fraction is already in its simplest form. It cannot be reduced any further. We have to show the teachers that we understand what we're doing. They're not going to trick us, right? Sometimes they put these things to drive us crazy. And they don't know that we know. We know. We can't be tricked about these things. So we have 2 over 14. These are even numbers. We know 2 can go into them. 2 into 2, 1. 2 into 14, 7. That's 1 over 7. And finally, we have 16 over 20. 16 over 20. They are both even numbers. We can use 2, but can you also think of another number, a bigger number than 2, that can divide exactly into 16 and exactly into 20? Because when you're reducing fractions, if you can find a bigger factor, it's better for you. If you choose a smaller factor, you might end up having to reduce it again, because you're going to end up with a fraction that is not yet in its lowest form. So the bigger the factor that you can find that's common to both the denominator and the numerator, the better it is for you, the quicker you'll reduce it. So instead of using the 2 to divide and get 8 over 10, which can be reduced again, we're just going to use the 4. 4 can go into 16, 4 can go into 20. So 4 goes into 16 4 times, 4 goes into 20 5 times. And this cannot be reduced any simpler. So 4/5 is the simplest form of 16 over 20. Did we get any other 4/5? No, we didn't. Alright, so to recap, we said that to reduce a fraction, we divide both the numerator and the denominator by the same factor, the common factor. Many fractions can be reduced to the same simple form, and we call those fractions equivalent fractions. So we found that for, I think we found that for 3 sets. We found it for the half, 2/4, 3/6, 7 over 14, 10 over 20. They all are equivalent. They all can be reduced to a half. We also found it for 3/4, the 9/12, 15 over 20, 3/4 itself, 6 over 8. All of those are reduced to 3/4, so they are equivalent. And there was one more, I think it was the 1/5, 5 over 25, 3 over 15, 2 over 10 are equivalent fractions because they all can be reduced to 1/5. Alright? And we have many fractions that are equivalent. Once you can reduce them to the same fraction, they are equivalent. And I did a video just on equivalent fractions, so you can go ahead and search for that video to explore that topic more in depth. Alright, so that's it for reducing fractions. Remember, you must be able to master this before you can go on to adding fractions, subtracting, multiplying, dividing fractions, and so on. And changing improper fractions to mixed numbers and mixed numbers to improper fractions. They all involve some kind of reduction. We also call it cancelling. Reduction is the preferred term, right? But you will hear a person say cancel the fraction, reduce the fraction to its lowest terms. Alright, so I'm trusting that you have been helped by this video, and I'm also encouraging you to share the video to your friends, neighbors, classmates, anyone whom you think can benefit from watching the video. If you have been helped, please drop a line in the comments to say thank you, miss, for sharing the information. And if you have any topics that you'd like for me to do a video on, I'd be happy to do that. Just let me know in the comments which topic you'd like me to feature. So my scholars, take care of yourselves, and I'll see you in the next video.